In this section, let's discuss two examples to calculate Norton's equivalent resistance of an electrical network using method 1.
Now let's see an examples in method 1. For that, let's consider these circuit. Here we can have only one independent sources and two dependent sources. Here the question is obtain Rn, that is Norton equivalent resistance of the circuit shown in figure. So as we know, the first step is to find open circuit voltage across the open circuited terminals A and B by means of conventional method. Conventional method may be by means of Kirchhoff voltage law or by means of nodal analysis. Here we can see some inner loop is there. So this is the inner loop. So that is separately drawn here. So when we are considering the inner loop, so let's consider this inner loop current as Ix. Suppose we are writing KVL over here, the equation become 5 minus 10 Ix minus 5Ix minus 10I2 is equal to 0. So when we are considering the circuit, here Ix is exactly equal to I2 and I1 is just opposite to Ix, that is I1 is equal to minus Ix. So from this circuit, Ix is equal to I2 and I1 is equal to minus Ix. So by using these expressions, we can modify this KVL equation like this. So 5 minus 10Ix minus 5Ix minus 10I2 become minus 10Ix is equal to 0. Simplifying, we can obtain 5 minus 25Ix is equal to 0 and Ix can be obtained as 5 by 25 which is equal to 0.2 ampere. As I1 is equal to minus Ix and Ix is equal to I2, I1 can be written as I1 is equal to minus 2 ampere and I2 is exactly equal to Ix, therefore I2 is equal to 0.2 ampere. So from this inner loop, we got the value of I1 and I2 as this one. Now let's consider the outer loop, this loop. So this is the outer loop. In this outer loop, if we are writing the KVL equation, the equation become 5
minus 10I2
plus 3I1. Here as it is open circuited, current through 10 ohm resistor is 0. Therefore minus 10 into 0 and this is the open circuit voltage. So minus VOC is equal to 0. 5 minus 10I2 plus 3I1 minus 10 into 0 minus VOC is equal to 0. From this, when substituting the value of I1 and I2 like this, we can obtain VOC as 2.4 volt. Now we got the first step, that is VOC across A and B by means of conventional method. Second step in method 1 is we need to short circuit these open circuited terminals A and B and we need to find out current through that of short circuited terminals, that is ISC. So this is the corresponding condition. Here the terminals A and B get short circuited. We need to measure the current through the short circuited terminals, that gives ISC, which is equal to Norton equivalent current. So let's consider this circuit. In this circuit we can have two meshes, mesh 1 and mesh 2. Say the current through mesh 1 is Ix and the direction is like this, and current through the mesh 2 is Iy and the direction be like this. Now from this circuit it can be written as Ix is exactly equal to I2. So whatever be the mesh current 1, that is Ix, that is exactly equal to I2. And similarly, what is the current flowing through this branch? This current Ix is coming down. Iy is same as that of I1 direction. So the current through this branch I1 can be written as Iy minus Ix. That is Iy minus Ix is equal to I1. So these two things are very important. Now let's consider mesh 1 equations. So when we are considering mesh 1 equation, the equation can be written as 5 minus 10 ix minus 5 ix minus iy minus 10 i2 is equal to 0. Simplifying, 5 minus 10 ix minus 5 ix plus 5 iy minus 10 ix is equal to 0. Why? Because i2 is equal to ix. So further simplifying, we can obtain this expression 25 ix minus 5 iy is equal to 5. Let this be the equation number 1. 25 ix minus 5 iy is equal to 5. Now let's consider mesh 2. When we are considering mesh 2, let's write the mesh equation as plus 10 i2 minus 5 iy minus ix, that is the current flowing through 5 ohm resistor when we are considering mesh 2. So that is minus 5 into iy minus ix plus 3 i1. This current is iy, so minus 10 iy is equal to 0. 10 i2 minus 5 iy minus ix plus 3 i1 minus 10 iy is equal to 0. So simplifying these expression, we can obtain this value ix is equal to iy. Let it be equation number 2. So from this mesh 2, we can have this relation ix is equal to iy, that is current flowing through mesh 1 is equal to current flowing through mesh 2. So when we are substituting equation number 2 in equation number 1, equation number 1 becomes 20 ix is equal to 5, that is ix is equal to 1 by 4, that is 0.25 ampere. That gives Norton equivalent current or short circuit current through these short circuited terminals. So once we got VOC and ISC, Rn is equal to VOC by ISC, substituting VOC as 2.4 and IN as 0.25, we can obtain Norton equivalent resistance as 9.6 ohm. Now let's go through another example in method 1. This is the problem. In these problems, we need to find out Rn, that is Norton equivalent resistance. In this problem, there is one dependent and independent sources. Independent source is 10 ampere, that is current source. This is a controllable voltage source. The value of this voltage source is controlled by the voltage drop across 2 ohm resistor. So it is a voltage controlled voltage source. So in order to find out Norton equivalent resistance by means of method 1, first of all we need to find out open circuit voltage VOC. Then we need to short this terminal and we need to find out IN, that is ISC. So considering this circuit alone, we can write this expression here. So let's consider this loop current as I1 and this loop current as I2. Since one dependent source is available here, so further simplification we can use this super mesh. So when we are considering this circuit, we can write 10 ampere as I2 minus I1, that is I2 minus I1 gives 10 ampere, and whatever be the voltage across A and B, that is VOC, is exactly equal to Vx, that is the voltage drop across 2 ohm resistor, that determine the value of this voltage source. So these two things are important here. Now let's consider super mesh. This is your super mesh that is separately drawn here. So when we are considering super mesh, current through 6 ohm resistor is I1 and current through 2 ohm resistor is I2. Considering all these concept, we can write the voltage equation as minus 6 I1 minus 2 Vx minus Vx is equal to 0. that is minus 6i1 is equal to 3vx. And from this circuit it is clear that what is vx is equal to i2 into 2, that is 2i2. Substituting, we can obtain minus 6i1 is equal to 6i2, or in other words, i1 is equal to minus i2, or i2 is equal to minus i1. When we are applying equation number 2 in equation number 1 here, we can write i2 minus i1 as i2 minus i2, that is 2i2 is equal to 10, and i2 is obtained as 5 ampere. So Vx, that is VOC, is equal to voltage drop across 2 ohm. Current through 2 ohm resistor is I2, that is 5 ampere. So 5 into 2 gives VOC or Vx, that is 10 volt. The first step in method 1 is obtain VOC by means of conventional method, and we got VOC as 10 volt. So next step is obtain the short circuited current by short circuiting the terminals A and B. When we are short circuiting the terminals A and B, the current flowing through these 2 ohm resistance becomes 0. Why? Because current will flow through easiest path. So this is your ISC, short circuit current. When current flowing through 2 ohm resistance becomes 0, Vx becomes 0. Why? Because Vx is equal to this resistance into current. So Vx becomes 0. When Vx becomes 0, this voltage source becomes 0. So correspondingly, the equivalent circuit become like this. 6 ohm, this is your 6 ohm. Then this is current source. This voltage source is 0. It can be short circuited. And this resistance, current flowing through this resistance is 0. So there is no need of representing that one. It is just like open circuit. So this is the equivalent circuit corresponding to that situation. Again, when we are considering this circuit, current flowing through 6 ohm resistance is 0. So this entire current 10 ampere will flow through these short circuit terminals. So IS is equal to 10 ampere. That is your Norton equivalent current. Now we can calculate Norton equivalent resistance as VOC by ISC or VOC by IN, and it is obtained as 1 ohm.